Hello everyone, welcome to AD. So now we are going to solve this question based on equilibrium of forces. As you can see, we have a diagram where we are asked to find the value of T1, T2, T3 and theta, which is the angle of inclination. So let us see how we can solve this. So firstly, you could have observed that there will be two nodes here. One node will have T2 as the horizontal force in the right direction, and T1 inclined at an angle of 35 degree and 40 Newton force acting downwards, and the second node will be for T3 acting at an angle theta, a force of 50 Newton acting downwards, and T2 in the left horizontal direction. So as you could have observed that we have made two nodes, and the reason is because we need to find four variables here, which is T1, T2, T3 and theta. So with any node you can only find T1 and T2 or angle. So whichever the variables are given, you can only find two variables from one node, because as you could have solved previously using Lami's theorem, we found two forces where angle was given. But here the angle is also missing in one figure, so we need to find the value of one of the forces, which is either T2 or T3, to find the theta. So we can only find the value of two variables using one node. So that is why we need two nodes, where firstly we will solve for T1 and T2 because the angle is given as 35 degree, and then we will take this value of T2 and put it in the second node to find the value of T3 and theta. So this is how we are going to solve this. So firstly let us apply Lami's theorem at node 1. So let us call this as node 1, this is node 2, and we have this angle as 90 degree, which makes the angle of T1 between T1 and T2. So let us say angle between T1 and T2 is nothing but 190 plus 35, which is nothing but 125 degree. And then the angle between T2 and this 40 Newton force is 90. Similarly, the angle between T1 and this 40 Newton force will become 90 plus 90 minus 35. So let us calculate it. 90 minus 35 will become 55, and if you add 90 to it, it will be 145. So this whole angle becomes 145 degree. You can also verify this by adding up all the angles, and if it comes out to be 360, so these 290 become 180, and 145 and 35 will become 180. So 180 plus 180 will become 360. So you can verify this also by using this. And then let us apply the Lami's theorem. We have 40. The statement of the Lami's theorem states that the force is proportional to the angle between the other two forces, which is nothing but the angle between T1 and T2. So the force 40 will be proportional to the angle between sine of the angle between other two forces, which is T1 and T2. So it will be 90 plus 35, which is 125. Similarly, T2 will be proportional to the angle between 40 and T1. So it will be T2 by sine of 145. And the T1 will be proportional to angle between 40 and T2, which is nothing but sine 90. So this is how we can apply Lami's theorem at node 1, and we have sine 90 value as 1, and we have been given 40 as the value of the third force. So we can find T1 and T2 using this equation, which is nothing but T1 by sine 90 is equal to 40 by sine 125. This is the first equation, let us say, and T2 by sine 145 is equal to 40 by sine 125 is the another equation which we will use to find the value of T2 and T1. So T1 we have as 40 by sine 125 into sine 90. Sine 90 value is 1, and sine 125 can be written as a sine of sine 125 can be sine of 90 plus 35, which is nothing but cos 35, because sine 90 plus theta is cos theta. So this will be 40 divided by cos 35 So 40 divided by cos 35 becomes 48.83 as the value of T1. Similarly, we can find out T2, which will nothing but sin 145 divided by sin 125 into 40. So sin 145 can be written as sin of 90 plus 55, so it becomes cos 55, and the lower will become sin cos 35 into 40. So the value of cos 55 is 0.573 divided by cos of 35 will become 0.7 into, let us say, 40. We have 28 Newton as the value of T2. So as you can see, we have found the value of T1 and T2, and we will use this T2 to find the value of theta, this angle theta. So let us draw this second diagram. We have T3 at an angle of theta, we have T2, and we have 50 Newton. So one thing you could have noticed that we have applied this T2 force as a tensile force. So always whenever there is a node and there are strings attached to it, the force at the node will be tensile for the string, and the reaction forces will be like compressive forces. Like let us say this is the roller resting on a surface, so the force due to the reaction will be compressive, like this towards the center of the sphere. But whenever the strings are attached to a certain point, the force due to the string will be always tensile, because the string cannot apply a compressive force at any point. So let us say we are solving for this. We have applying Lami's theorem. We have T3 divided by, let us say this is T3, this is 90, this is again 90, and this is nothing but 180 minus theta. So we have T3 divided by sin 90 is equal to 50 divided by sin of 90 plus theta is equal to T2 divided by sin of 180 minus theta, which is nothing but T2 divided by angle between other two angles, which is 50 and T3, and which is 180 minus theta. So let us solve this further. We have T3 is equal to sin of 90 by sin of 90 plus theta into 50 as our value of T3. So as you can see, we have a variable theta also. We need to find first the value of theta. So let us first try to solve for value of theta. We have 50 by sin 90 plus theta is nothing but cos theta, and we have T2 divided by sin 180 minus theta will become again sin theta. So we have tan theta, which is nothing but sin theta. If you put it here, this will be sin theta by cos theta, which is tan theta, and it will be T2 by 50, and the value of T2 we have previously calculated as 28 Newton. So it will be 28 by 50. So let us calculate 28 divided by 50. It is 0.56, and if you apply tan inverse of that, it will be 29.2. So let us say that theta is approximately 30 degree. The exact answer will be 29.3 something, but you can approximate it as 30 degree. So let us move further. We have T3 as sin 90, which is 1 divided by sin 90 plus theta is cos theta, and cos theta is nothing but cos of 30. So it will be cos of 30 into 50. We have cos 30 as root 3 by 2. So 50 divided by cos of 30 will be 57.735 Newton as your answer. So as you can see, we have found out the value of T3, the value of theta angle of inclination, and value of T2 we have found here, and T1 also we have found here using Lami's theorem. So this is how you can solve this question. Thank you.